Good evening, everyone. This is Tony Miraker, and I am the section chair in Toronto. We have a great meeting on for tonight. Let me just move along our slides here. So tonight's sponsor is SMPTE Toronto. And I'll put a little plug in here that if you're not a member yet, then please point your browser to membership.smpt.org/store product/professional, and that'll take you right to the screen. So this evening, the presentation is going to be on the CBC new building in Montreal. Talking about the ST 2021 initiative that they have got themselves nicely wrapped up in. This meeting was arranged by Craig Yasmin, Peter Armstrong, and myself. So presentation will be from Francoise Legrand and Felix Bellon. And what they're going to be in a video that was recorded about a month ago. So we will, after my opening comments and opening remarks, we will play the video, and then we will have a Q&A live session afterwards. So I just wanted to touch upon the SMPTE board. It's a new board that started in September. Well, actually started in July 1st. So I'm your chair again for another 2 years. Sylvia Fenton's secretary treasurer again. Because I haven't been moving, Lee automatically becomes the past chair again. And right now, until the end of December, Paul Briscoe is the regional governor. Now, there is an election in play right now, so if you've gotten your email from SMPTE Home Office as a member, you should participate in the election process. We have 3 new and returning managers. There are 6 managers in total. So Stosh is returning. Roy Falkman is new to the board. Welcome, Roy. And then Craig is returning for another 2 years. So their term is from 2021 to 2023. Now, returning again, because this is their second of a 2-year term, is Gleb, Jamie, and Kevin. So they're back again for another year. And again, the cycle is every other year. We have 3 new managers, so they will be till I think June of 2022. And we'll have another election. So if you're interested in participating in the board level, do let us know. Now we have 3 new managers at large, and managers at large to us are managers that want to participate in the board and help us out, but they're not an official elected through SMPTE Home Office. They are elected through the local board, but they are not elected through an election process through membership based. So Silvino, Ilya, and Jeff are new members, and they are running for 1-year term and till June 2022 as well. We have some special board members, or sorry, managers, and that's Nadia Aftab. She is our membership chair. We have Peter Armstrong as promotion advisor, and Rick Grunberg is our student advisor. Now, what we've sparked up again this year is the SMPTE Western Canada subsection. And the chairperson that has been elected is Brian Gattensby, and the secretary treasurer is Rick Sederland. So both Brian and Rick will be working for the Western Canada subsection. They will, we had a meeting today, and there'll be meetings in that part of Canada as well. So there'll be, we'll be helping them as they go along, and we'll get that subsection up and running and active. Just so you know, Montreal has a subsection, which is Ottawa. So the Ottawa subsection is part of Montreal, whereas the Western Canada subsection is part of the Toronto section. So tonight, the evening will be, Craig will introduce and read the bios of the presenters. Peter and I will manage the chat room. So there is a question box that you have access to that you can put your questions in, and we will review them and read them. And also the presenters have access to the question boxes as well. But we're going to leave all the questions to the very end of the presentation. And on that note, Craig, I'm going to send it off to you. This is a picture of the building in Montreal, and quite a nice building. And I will let you take it from there, Craig.
Sure. Thank you, Peter. Hopefully, if I keep talking, it'll stay on me, so that's good. So yeah, just first comment, I know Tony has already mentioned it, but the video presentation we're doing first for you today was originally pre-recorded. So it does kind of give the impression it's live, but it actually isn't. But the question and answer period we're doing is live, and we do have like Felix and Francois like actually in the MRC today to answer our questions. So Peter, you want to go to the next slide? Okay, cool. So first I wanted to introduce Felix Pion. So Felix has been with CBC since 2007. He's the director of the Media over IP Architecture and Lab, a group that we pretty heavily lean on during this process for all of our IP needs, which are very heavy for CBC at this point in time. Before joining CBC, Felix was a leading expert in IP at the European Broadcasting Union in Switzerland for 6 years. During his time, he also worked on a VTR sandbox live IP proof of concept studio, which was award-winning. It won multiple awards in 2016. Felix completed his diploma in electrical engineering at Montreal's Polytechnica and finished his thesis at MIT in 2012. He also co-chairs the Nmos steering committee, and he was awarded the 2020 fellowship for SMPTE in the fall conference. Yeah, so that's, and then one of our other presenters is Francoise Legrand. So Francoise Legrand joined CBC in 2004 as a systems designer. During his time, he spent included building digital TV and radio stations and supervising large-scale projects. In 2005, he became a professional electrical engineer, got that designation. He's held several management positions at CBC, and currently he is the director of core system engineering, where he manages a team responsible for all capital projects and core infrastructure. And also we have one other, do you want to go to the next slide?
I don't have a bio for.
Okay, great.
Yeah.
Yes. All right. I'll introduce when we actually do the questions, but we do have one other participant who's going to help us with our questions, and that's Francois Payer. So he'll also include, and he's also a systems engineer at CBC. So, all right, Peter, it's all yours.
So Peter, you can roll. I guess you can't say roll tape anymore, can you?
No, I'm going to roll the file. Here we go.
I'm very excited to welcome you in our new broadcasting house. I'm in the Studio K that will be used for news show in the next few months. In this session, we will talk about the live IP technology in action with some real-life implementations. I've been involved with NTS since 2011, where we talk a lot about the new media over IP technology, discuss architecture and standards, and we are at the point we can see concrete results from all the effort that were put together by the broadcasters, standard bodies, and partner vendors. We will present some great examples today. As first presentation, we took the opportunity of this virtual edition to bring you all in Montreal. We are in the middle of our migration of our new production facility, and this is a greenfield building. In practice, it was actually a gray parking lot rather than a greenfield, but you know what I mean. Construction started back in 2017 with the data center part of the building delivered in August 2018, so that we could start the physical installation of the back end whilst the rest of the building was still in construction. The new facility is 40,000 square meters. That is only a third of the space we had in the whole building that became too vast for the production needs. It is composed of 2 towers, one with 7 floors and the other with 4 floors. The main entrance, we call the atrium, is a vast open space that will be open to public between the 2 towers. Another section for the technical spaces is only 2 floors high that allow for the earlier delivery of that part. In this building, we produce content for a general TV channel, a continuous news network, and specialty cable channels and online platforms, for our French language network, and for the regional presence of the CBC English network. We have a talking and music radios and an ever-growing number of online contents. In a few moments, we will go visit some of the production spaces. In addition, we have a number of alternative production positions, including the atrium, a rooftop terrace, and a park with a nice point of view on the city landscape. And most welcomed by the staff, a lot more natural light thanks to the glass wall, where a big part of the old building was actually underground. We will now join my colleague Francoise Legrand, who is currently in the control room and will give us a tour of some interesting facilities of the new building.
Thank you, Felix. Here is control room 22. This is the control room that we are using right now to produce this live show. It is one of 4 identical control rooms that we are using to create local news, national news, as well as various types of programming for RDI, or all-day news network. It is a fully automated control room. And today we will speak with Vincent and Alex that are proud users of this control room. So welcome to the show, Vincent.
Thank you, Francois.
So can you give us a short explanation of each one of the positions used in this control room?
Yes, of course. In the control room, since it's an automated control room, we have 2 switcher directors that have 2 main objectives. The first one, myself, is to be helping Alex with the show, prepping everything, making sure the peripheral devices are working well. As the audio console or iNews, making sure the comments are correct, and the TV prompter too is following. On the front of the control room, you have Alex, which is the main switcher director. He's controlling overdrive, which is a rundown created prior to the show with templates pre-organized. And through iNews, he sees his rundown, and after that he can edit the show live as he's doing. On his side is Marianne. She's the script. She's the one giving countdowns and making sure the time of the show is respected. Every one in the show needs to respect the timing they have, so she's the one who's following this. She's doing the supers too, making sure graphs on hair doesn't have any mistake in it. And after that, we go to the row behind. We can see Pascal, which is the technical director. If there's any trouble in the control room, we can go to him, and he's the one leaving the room, making sure everyone knows what is the problem, and he can manage everything around it. Besides him is Joelle. She's the director of the show. She's creating the pacing through in iNews for her show, and she's actually talking with the people outside, the reporters and the hosts, to make sure the show goes well and according to plan.
Thank you, Vincent. You spoke about iNews and Overdrive. Are they other important technical system that you are using in this control room?
Of course, with Overdrive comes the Acuity, is the video mixer that we're using. This is the main component of the control room, which is talking to every device in the control room. We are using a Lavo MC2 Square 56 as audio console. We don't necessarily operate it on time since everything is automated. But as a second switcher director, I can manipulate audio and make sure the levels are perfectly correct without screwing the rest of the show. We are using for graphs VisRT, and for monitor and graphs and monitors, we're using Expression, which is a Rust project too. And for playbacks, we're going to use EVS.
Thank you very much, Vincent. This is very interesting. And now we will speak with Alex. So welcome to the show, Alex.
Thank you.
So you went through a previous transition that was to go from traditional control room to fully automated control room.
Yeah.
Would you say that moving from SDI to IP is a bigger or a smaller transition than what you did many years ago?
Well, switching from SDI to IP is not a big change for most of the people. The production team will not see most of the changes because it's more of a back-end thing. For the operators that are more technical, the IP infrastructure, in fact, gives more flexibility and opportunities to manage the inputs and the outputs of the control room. So there are no big changes for the production team. The changes are more for the technical team. But in the control room, the main component we use are pretty much the same. So the audio mixer, the vision mixer, you know, we are not lost in this environment. The big thing that is changing is the master router, that is VSM in our case.
So what are the big difference by going to IP?
Going to IP, well, it's mostly the use of that panel, which is a VSM panel that allows us to control all of the inputs and the outputs of the control room. So I can, with this system, subscribe this particular control room to any of the studios that are available throughout the facility. So all of my auxiliaries, both video and audio, can be subscribed to a destination, which is any of the studios that are available in this facility. And I can do that with the simple touch of a button. You know, it's really simple. I hit those buttons, and then I take the control of any studio that I need. So that's one of the major improvements we have with that routing system. And also I can retrieve any inputs that are available throughout my system. So it is really convenient for the technical side for the production.
This is really impressive. Quickly, you spoke about the advantage.
Yeah.
Can you give us one big disadvantage or hurdle that you went through while setting up this facility?
Well, the VSM gives us a lot of flexibility, but most of the little challenge that we faced are more with the capabilities of the end devices. So I can make any switch I need as long as the device can take it. And one of the problems that we faced at the beginning was the lip sync issue, because we realized that the audio was going much faster than the audio was going much faster than the video. And so we had to calculate what was the video and audio delay that we should apply, but there was no 2110 tool to calibrate that. So you and your team, I know that you have worked really hard to find a way to capture the streams and analyze them, and to find the right delay and where it was coming from in this infrastructure, because it is more complex to do the troubleshooting, because a lot of the concept and a lot of the management is virtual. So we managed to find the right delay in the environment and apply it to the output of the control room. So we go on with that, and we try to get the system to work the most efficiently.
Thank you very much, Alex. Now back to you, Felix.
And when Alex talked about the challenge of audio-video alignment, this is a good example of innovation where EBU could help us. We worked together with the EBU list team to develop a tool that can measure audio-to-video delay in the IP packet level. This tool was useful for us and now is available to anyone using List. Back to the visit, the second floor of the Maison is dedicated to our continuous news channel. The control rooms and studio floors are built around the newsroom so that journalists, news anchor, and production crew desk are very close to the show location. Every radio studios for news are on the same floor, even the radio, as our editorial teams are covering all the distribution platform, be it TV, radio, and online. When all the move is completed, we will have 1,000 staff working in this news center. That is 700 editorial and 300 technical people. Francoise now moved to the next room where we go back to him.
Thank you, Felix. I'm now in the acquisition room where we will meet Yvan Martin Lévesque. Yvan Martin, welcome to the show.
Hi, thank you, Francois, and welcome also.
Yvan Martin, can you explain to our audience what is the purpose of this room?
Absolutely, Francois. This is the acquisition room. You know, in our business, we need to manage two different worlds. One is the ENG world, the people on the field with their standard, their audio assignment, their different quality, because we have professional cameramen and we also have people at home with FaceTime and Skype and such technology. And the people working in the control room, which are more on the broadcast side. So they put together all of those feeds and make ready to be on the air product. So the gateway between both worlds is here in the acquisition room. When we get all of those feeds, we prepare them, we check them, and we send them to the people which will be using them for their production.
Thank you, Yvan Martin. Can you explain me what are the various tools that you use daily to do your job?
Yes, here we are really at the heart of the IP system. So we use the Orchestrator, which in our case is VSM. We use the intercom. We are an AV user of the recording system. And of course, we have control tools such as the Prism to analyze and check the signals.
So can you tell me what were the main challenges from switching from HD SDI into IP?
Actually, people here in the room need, of course, to understand what is IP and how it's work. But the main challenge is really how to use this new technology, how to think IP. And a really fast examples to illustrate all this. In SDI, you want to check a signal. A signal is basically something that you can touch because it's a cable. So you have to plug it in the monitor and you see if it's working or not. In IP, there's many streams. All of those are multicast addresses. They are not physical things that you can manipulate. So you need to really think out of the box. And coming from an SDI world, for let's say a 25 experienced technician is quite sometimes a challenge to make this change, but at the end it's a lot more flexible.
So we've heard a little bit earlier from the people in the control room that for them the transition from SDI to IP was easy because the new control room feel just like the old one that were SDI. So here for your team, was it the same?
Absolutely not. It's quite different because, as I said, now a source is not anymore something that you can feel, that you can touch. But at the end of the day, the people has a lot of experience in this in their job. So the experience pay back because what is changing is the tool. So how to think IP, how to manage those virtual things. But this flexibility sometimes, if it's not well managed, can lead you to some problem later on. But it's a fun challenge, and actually, after a couple of months having our hands into that system, we will never go back for sure.
Can you give me one example of a problem you had to solve in the transition to IP?
Yes, of course. You know, in SDI, you have this habit that over the time tells you that since audio is traveling with the video in the same cables, there's no more lip sync issue. While in IP, it's the opposite. So you have to check everything. You have to check that the sync is accurate, and also you have to make sure that because it's virtual, to think about all the possibility. And a good example for that is we used to in SDI to send our signal and rely on the other end to make sure the signal is arrived. Since an IP, you can take your own multicast and look back at you.
Thank you very much, Yvan Martin. And
My
now
pleasure.
back to you, Félix.
Thanks, François, and I'm pleased to be with the Senior Project Director, Stefan Dion. Bonjour, Stefan.
Bonjour, Félix.
Considering the complexity of moving our production broadcast center and moreover with a lot of new technology, how did you approach this challenge in the management of the project?
That's an interesting question, Félix, and the answer does come from a different aspect. First of all, I think it's important to mention that it wasn't feasible to know in advance the exact sequence of tasks and their dependencies that would bring us to a level of being able to produce radio and television in the new building. Based on that, trying to use a standard Gantt chart was simply useless. Another aspect that we had to keep in taken into consideration is the fact that most of the people working on the project were technologists, and their perception of completion is based on reaching a point where 100% of the work to be done is from a technology standpoint. But the real goal of the project was to be out of the old building. It's not as cool as saying that you're building a state-of-the-art IP broadcast center, but recognizing that did help a lot in clearly identify the critical path of the project.
So, if not the technology, delivery of technology is the goal, what's the one target for the teams?
Yeah, what we did is focus on delivering business value instead of technical value. That helped to understand what should be prioritized, and it helps a lot also to align all teams to the same objectives. Being all aligned like that also makes it easier to communicate priorities, progression, challenges to the different stakeholders of the project. And when I talk about stakeholders, I mean board of directors, executives, managers, technicians and engineers, but also the vendors as well. With having clear business objectives, it was easier to make alignment with them as well.
So how did you achieve that in practice?
To keep the alignment was clearly going to be a challenge in the long run. So what we did was subdivided the project in 3-month periods. And then after each 3 months, we measure progression and we redefine the objectives for the next 3 months. And that is always done with the critical path in mind. Technically, behind that business-oriented philosophy, we were deeply influenced by the agile methodology, and the team members were grouped in squads, specialized squads, with a product owner, and the work itself was defined in the usual agile stories. And for some of the squads, there is 2-week sprints, and for other squads, there was simply Kanban boards.
Yeah, and we use the Jira tool as well, which
Absolutely.
is a very good mean to connect everybody using this approach. How does it work to move a continuous news channel without interruption? and while the complex system is actually still being deployed?
Yeah, that's a complex question, but one thing sure is that you cannot complete the deployment before you start the migration. There's an old saying that says that the proof of the pudding is in the eating. So you absolutely need to use infrastructure in the real world environment to be able to complete that deployment, but also to stabilize it and complete the training. At one point, you have to take risk. The question is how you calculate that risk. For us, it was to start with a news show that had a smaller audience, that was outside prime time, and that we had a contingency plan that was easy to deploy in case that something goes wrong.
And as a last question, for the benefit of our colleagues from other broadcasters who are about to do a similar project, is there anything you would do differently?
One thing I would surely do is take more time to understand the impact of the project on on how people do their regular job and all the cultural way of working in the enterprise, just to make sure that they can still manage that daily operation while working on the deployment and the migration at the same time. And maybe one other thing I would do is invest more in the training ahead of the migration that we did.
Thank you very much, Stefan.
You're welcome, thank you.
And Francois is now in the atrium for the continuation of the visit. Francois.
Thank you, Felix. We are now in front of radio studio number 1. This radio studio is used by Ici Première, which is one of our radio network. And we are here to meet with Michael Néron. So Michael, welcome to the show today.
Thank you.
Can you tell us how is the move doing for radio?
It's actually going very, very well. We have so far transferred from the old building to the new facility something about 45 different radio production and podcast. And most of the summer programming will be done here in the new building, which is a great thing for us.
So can you tell me what the team like and what they dislike about their new working environment?
The main thing they like is the light of day. As you can see behind us, the radio people are not used to have windows in their studio. It's something that they really like, but more than anything, it's the fact that we've put a great deal, despite the fact that we have all new equipment, all new studio, that we didn't change the workflow of a radio production. So when they get in, they do the exact same thing as they always did, but with new studio and new facility, new equipment.
By looking at the picture that we see right now on the screen, we can see that there's very little equipment in those control room. I don't see any CD player, no turntable, no tape machine.
No.
So is this something new for the radio production teams?
Well, it's not something new. It's something that slowly went out within in the past years. You know, we've had this in the older studio, but we were not using it as much as we used to. And now mostly everything is file-based, so it's all ingested within DALE, and it's our main playout in the studio, so that's what we use.
I know that for radio people, sound quality is very important. Mm-hmm. So can you tell me if IP can sound great?
It sounds great. We noticed it. The first show we've had on air, we were like, wow, it sounds fantastic. The studios are great. The environment is great. We've put a lot of time choosing the proper equipment. And we have the Lavo equipment in the studio, the power core, great preamps, great stuff. So we're pretty happy about it.
So thank you very much, Michael.
Merci.
It was very interesting. So now back to you in the studio, Felix.
While Francois is moving to the next room, we look at the different types of radio and audio studio we have. We have 18 radio studios of different size. 5 full size with dedicated control room, 3 medium size with in-studio operator like the one we see now, 1 for multi-channel recording, 9 that are self-operated, 5 cabins, and 3 mixing rooms. And this is an example of the big studio for the morning shows, where we can have much more people than what we see when pandemic is over, including a music band if we need. Since we use the same technology for all of our audio system, that is AES-67, we can produce audio for any platform from anywhere in the building. We see here a typical control room. For the newsroom, we see the Lavo console, all the different equipment. It's quite neat. There's not a lot. It's really displays and control surface we have in those rooms. Most of the equipment supporting that are in a central control room or in a telecom closet on the floor. This is a telecom room. So on different floors, we have those rooms where we do all the interconnections between the studio and the central equipment room we will visit later. Francois is now in the Media Presentation Center for a visit of this critical room.
So thank you, Felix. We are now in Media Presentation Center. We are here to meet Daniel Lachance. So Daniel, welcome to the show.
Thank you for having me.
So can you explain to our audience what is the purpose of this room here?
It's the presentation center. Basically, all the different platforms we're diffusing on, like radio, which is on this side of the building, the room, I should say. And we have the web as well, which is in the other corner. And basically television, which all basically were in different rooms before. Now we're all concentrated in the same room.
Can you tell me how many TV, radio, and web channels you were playing out to air from this?
There are 67 channels for radio, and there's 17 channels for television, 13 for the SRC itself, and a few specialty channels. And I'd like to precise that in the specialty channels, there's the news channels, which is called RDI.
And why is there so many channels? Can you explain that to me?
It's because of the time zone of the country. We're diffusing for the Canada, and there's several of them. And basically, the radio channels, 67 of them, they span all across the country, which is the same for television as well for the SRC. And basically, a bunch of those, not all of them, but a lot of them, are also streamed on the web. So basically, they're a replica of what we put on the air for television and radio, but on the web.
What are the main tools that you are using in this room?
VSM is our best friend, obviously, because now, like you can see on those screens over there, VSM is being used to follow the signal flow of everything that is coming in the room and outside of the room. And in the middle, at the heart of it all, is ITX from Grass Valley.
So is the ITX a full IP solution?
Yes, absolutely. ITX was used before in the HDSDI environment in Toronto, but they presented us with a new solution using 2110. And we were glad to see that we could use it in all of our different platforms. So basically, web, radio, TV, we're all using ITX now.
And are you using other IP tools in this facility?
Yes. A little bit, just like Yvan Martin-Lévesque explained to you a bit earlier, one of the big part of what we're doing is surveillance, making sure that everything is fine. So we need to use the Prism from Telestream to make sure that the signals are correct. And we use a bunch of different components that are being implemented using VSM itself.
Okay. In terms of redundancy, can you explain me what is the redundancy strategy for on-air playout?
We're going to have, like, for now, it hasn't yet been completely deployed, but the goal is to use a disaster recovery plan that we decided to implement, which will reproduce a part of what we're using in Montreal, in Toronto. And for the Toronto presentation environment, they're going to have pretty much the same thing that we're going to use for the disaster recovery in Montreal. So basically what happens is if there's something going on in one of the buildings, the other one can take over. But the operators can continue to operate the system because everything can be used at a distance.
So you told us earlier that from here you are doing TV playout, web playout, and radio playout. Is playout done for all platforms using the same tool and similar workflows?
Absolutely. And basically VSM has been implemented like everywhere. One of the main difference, I guess, depending of what platform we're using, like for instance, obviously in radio, there's no closed captioning. There's closed captioning for the French network and all the different rooms, because they're not necessarily here with us, but like all the rooms that are surrounding the presentation department are all part of the presentation team. And closed captioning rooms are right next to this.
Thank you very much, Danielle. This is a very interesting room, and I see that you work really hard with your team to make it work. So now back to you, Felix, in the studio.
Now we will show you our central equipment room. This room is actually separated in 3 sections. The equipment is distributed in 2 mirror rooms that are separated by a firewall. It is holding all the critical back-end equipment built as a state-of-the-art data center with very limited access by the staff. The third room is the Demarc Room, where all the interconnection between our systems and the outside world, such as cable distributor, are located. Let's now pay a visit in the CER, the Central Equipment Room.
Thank you, Felix. We are here in our Central Equipment Room. This room is designed to house all our technical equipment. We have 2 of them. This is CER number 2. We'll see CER number 1 in a while. This room is designed to accommodate up to 1 megawatt of technical equipment. You can see from above the electrical wire that brings the power from, we have 2 generators for full redundancy. It's 2 generators that give us 1 megawatt of usable technical power. Then we have 2 UPS, and after that, again, 1 megawatt of power available. And then the power gets through the busways above the rack. And those busways enable us to add or remove circuits to the rack without having to do any power shutdown. So in the both room combined, we have 12 rows of 13 rack each for 156 equipment rack. The rack layout is using hot aisle, cold aisle air confinement. So right now we are sitting in the cold aisle, so we can see from above the grill. We get the supply of fresh air by the upper side of the wall. The cold air goes into the room. It gets sucked through the equipment and expelled on the back of the equipment where we have hot air containment. It goes back to the ceiling and then to the CRA unit again, and it's circled back like this. During winter, we recover the heat generated by the equipment to heat the building. So I said that we were in control room, in equipment room number 2. That's because we also have a central equipment room number 1 on this side, where every critical equipment are mirrored between both rooms. So as an example, this is the core router for the production ecosystem. It's an Arista 7516 router. This is where we switch most of the 2110 signal of the building. So we have one here, but for redundancy purpose, we have a second one in central equipment room number 2, which is right there. The wiring strategy, every delicate fiber is done from above the rack, so we can see the fiber trays. Then it goes in that fiber management system to the equipment. We need a fiber management system because cut-to-length fiber is very expensive. So in order to go with standard cable length, we need a slack management system. Everything that is copper as well as ruggedized fiber is done in the computer floor. And the computer floor, it's only used for wire distribution. There's no air. It's not used as a plenum space, as an example. So this is the back of the equipment we use for the playout system. Just a regular server that was supplied by CBC. Those are the ITX server for TV playout. So you can see the 25 gig we use for 2110. And but other than this, they are really regular server. If we go on the other side, we'll see the front of those server. So this is playout equipment. For various reasons, we decided to have a different network router for the playout ecosystem, mostly because it is a segmented network. So this is the small 7508 router used for the 2110 of playout. Then the rest is pretty much just a bunch of server, regular Dell server supplied by CBC for the various applications. So this is TV playout done with ITX. We saw the back of those servers a few seconds ago. Then we have the radio ITX server, same model, just without the GPU, but it runs the same application. And then we have up here the server we use for tag, which is the software-based multi-viewer we are using for playout. The compute for virtual machine and the storage for playout file is done using those server here and the storage product below from NetApp. They are the same model and make as what we use for corporate and other media application, but for playout, again, because of segmentation, it's different units, but it is the same technology. So thank you for watching that small tour.
Okay, that's it for the video. If I can get Francois and the group to spark up their cameras. So we'll have Francois, Felix, and Jean-Francois available for the Q&A period. I am going to stop sharing my screen so that we can see everybody in full view.
All right, thanks, Tony. So I did just want to introduce again. So we have Felix on my right, or maybe your left, I'm not sure, in there waving his hand. And then we have Francoise Legrand on the left there. And then also we have Jean-Francois Pierre, also in the studio there. So so Peter, did you find any questions for us?
There's a couple there. Can you guys see the questions?
Yes, well, I can take the one about the power, if you may.
Okay, you want to reread the
well,
question?
Actually,
and then
Michael Boulet asked what happened when the power fell. We actually have a pretty huge generator on site. As Francois said before, we actually have 3 2-megawatt generators that feed, well, actually the 2 first one feed the studios and the control room, and the UPS for the data center. The UPS for the data center, we have 2 huge 1-megawatt UPS that feed the data center and the telecom closet, and 2 125 kilowatt that feeds the satellite room and the media presentation. And we also have the 3rd generator that feeds all the other building stuff, so the elevator, the fire safety, and everything. And we actually just did a test about about a month ago, to verify all of that. We had many surprises, but it was working fine. So we're pretty much all set for that.
So if I can just, it's Tony here, if I can just jump in, if we want to use the Q&A portion of Zoom and not the chat room, so then we'll just read all the questions off the Q&A. That's okay with everybody.
Yeah, maybe Francois can take over about commenting for the failover of the complete facility. I know there's a plan on the long term for that, but right now, I don't know where we at actually.
Yes, I can take this one. We have an extensive test plan to test the whole system before going on air. Some of those tests are already done because we are on air with part of the facility, and some are yet to come. In terms of failover or redundancy, most of the core system is fully redundant. So if we look at the network, we have a 2022-7 network. So that means that every piece of equipment goes through both network, and as long as one of the two is working, everything works fine. That was extensively tested, and it works great in theory, and it also works great in practice. There is very little audio device on the market that fully support 2022-7 or something similar in terms of redundancy. So that's why we were a bit restricted in the choice of audio technology. But what we got works great, and same for video. The ITX, the playout facility, today everything is double. So we have 2 full playout chain for every signal, 2 different multi-viewer, 2 storage unit, 2 VM farms. Everything is double. Both are installed in Montreal, in both CR, but at some point in the future, there's a plan to move some of those functionality to Toronto, and vice versa. When Toronto will be ready, we have a project going on today in Toronto to convert the TBC into an IP facility. So when it's going to be ready, we'll move services and exchange services between Montreal and Toronto. So I don't know if it answers the failover question. I hope it does. And if it doesn't, then you can ask the clarification in the question.
Okay, do we want to go and answer the first question about AI? Where do you see the need for AI, ML, and as you continue to integrate the various operations and engineering technologies?
That's a very good question, and something we have now that we didn't have before is ton of metadata. The amount of metadata that the different tools we are using can generate is quite amazing. Today, most of it, we keep it for 60 days. Why only 60 days? It's for storage reason. And we could use it in the future for to automate or better manage the facility. But to be honest, today we're not there yet. So we don't have any AI or ML assisted monitoring or stuff like that. It's still traditional, but IP is definitely an enabler for future projects around AI and machine learning.
I've got another question here. What is your experience in using Nmos and vendor IPs or APIs or APIs?
So you have to remember we started this project in 2017 with really the architecture and the design of the system. And at this time, Nmos was not widely available in all the devices. So we mostly started without using Nmos. We asked it in our RFPs. We worked with the vendor with the goal to use it more and more. And at some point in the project, we could start using Nmos with some of the devices.
There's a number of benefits of Nmos. The fact that it's a RESTful API, it's also a good, an easy way to debug and monitor. So there's some benefit to it. We had also it covered in part by our broadcast controller system that was not supporting it in the first place. So it arrives on the way. So I see the question is from Gord. For example, the Telestream Prism is a device we control now with Nmos, and more device in the future. So it's an hybrid like Nmos open specification and some proprietary protocols, including mostly Ember Plus that is widely supported in Lavo and audio products.
Okay, so Ethan, kind of you in the video you spoke of this, but he asked what was the biggest challenges of the SDI to IP transition, and where was the biggest learning curve? What would you do differently? So if there's a quick answer to that, I know you talked a lot about that in the video.
Yeah, one of the big challenges that we definitely were early adopter, and it was a great project. I like to learn, and we all like to learn in the team, and that was an amazing opportunity to work with the vendor to develop that technology and make it a little bit more mature. So I will say that early in the process, we had a lot of product that it was impossible to get a stable IP feed out of it or into it. So it was just that the minimum was not working. But as the technology matures, as the vendor mature, it became much more reliable. I believe that the knowledge to operate an IP facility is different than the knowledge to operate an SDI, or it's complementary. You need a bit more to do IP. So to have a significant mass of employees that master IP technology is a challenge. Maybe Felix, you can comment a bit on this, but yeah.
Yeah, and at the same time as we were learning ourselves, the whole industry was learning. So it was really a learning exercise. We did a lot of tests, a lot of trial and error, and trainings, and building our own trainings also internally. The staff who had a chance to touch it in the first place, they can pass on this knowledge to their colleagues. So growing the knowledge base. We were very involved also in the standardization and in the international community that were also building new projects, so we could exchange on the learnings. So yeah, that's really and we're still learning every day. And we're still also developing not only the knowledge, but also the working methodologies. You need to think of an IP-based production center as pretty much as a data center, more than a traditional broadcast center. And with this comes a number of tools, a number of methodology. It's much more software-based. There's much more software updates. There's much more configuration at play. So we developed our own methodology based on CI/CD systems that are used in the IT world, where we script the deployment of devices, and we script the modification of the network and of some of the devices, really to mimic how big data centers are operated, and that way they can stay on air and up and running for high availability.
Okay, and I'm going to combine two questions here. One from Frank that says, was any part of the facility operation designed to interface with cloud-based solutions? And also partly another question is, how much are you using the cloud? And what do you foresee using the cloud for in the future? And how are you handling work from home scenarios?
Okay, let's start with the cloud. CBC is, like many of you guys, we do radio, we do TV, we do digital web. 100% of the web infrastructure, it's all in the cloud. This is true for both French and English services of CBC. So this one is easy to answer. In terms of video or live TV production or live radio, we have a bunch of, let's say, administrative tools that are cloud-based, or accessory tools that are cloud-based. But in the core of the production system, to be honest, there's very little happening in the cloud. The work from home, it's interesting because we were in full deployment when COVID started, and it was really easy because the fact that everything is in the data center, people are working from their desk or at home, and they remotely access the equipment anyways, because there's very little that you really need to touch the equipment. It was very easy for the people doing configuration. For people that were building the shows or things like that, we set up a bunch of maquitos from Heyvision to stream SRT to people working from home. This is still in use as we speak. So that's an area where we use a little bit of the cloud, because we didn't want hundreds of users working from home to use the VPN to stream SRT streams at home. So this is an area where the cloud is great. So we had a bunch of Heyvision gateways running in Azure, and people are connecting to it, and we use that to ease the load on our VPN infrastructure and still be secure. So that's a great use we made of the cloud.
You can see the cloud really as an evolution of the transition to IP. So when you move your facility to IP, so to network devices, it enables a number of things. And the first thing is it enables the use of more software-based equipment and services. So instead of having a dedicated hardware specialty hardware doing something, you have a software and it's connected to network, so it has access to the video and it can stream the video in real time, and the audio and the ancillary data. So we are one step away from using the same software, but in a distant location rather than on-site. And basically, that's what we could call the cloud. If you have a very good connection or compressed stream, you can move these facility in the cloud. So I think for the very high end, like uncompressed, low latency stuff we do on site, we still stick with this in-house, very close equipment. But we're really a step away from remote production, and to be able to have some of those services not necessarily on site, but in a data center like one of the big cloud vendor. So, for example, you could talk about the Olympics, where we use a second site, but that site was actually really an extension of the main broadcast center.
Yes, that's and maybe that there's a side question I may answer at the same time from Brad Dixon about drama, variety, and all of that. So in the new building, we have 3 studio floors for drama with 2 control rooms. The control room, one of it is mostly delivered, and it was used this summer for the Olympic. but it was not used as a control room. It was used for the digital operation that were doing direct add insertion. They needed a room with multi-viewer and access to equipment and everything. So it was used for them. And the EVS were used, the VisRT were used, but remotely from another facility we have in Montreal, about 10 kilometers from the new Maison. And Felix is right, because in that facility, we mostly have control panels. All the core equipment that is in the new building, we were able to access it remotely and use it for the Olympic production. And of course, the two buildings were interconnected together in IP, carrying 2110 signal uncompressed between both facilities. To fully answer Brad's question, yes, all the lighting everywhere in drama, variety, all of it is IP based. What is maybe a little bit new is that in the past, the lighting network was considered a very, very, very chatty and sensitive network. So people were kind of afraid to merge that network with the rest of the network. In the new building, we have what we call the gray network. Gray is for everything that requires control. That's a production equipment. So that gray network is used for between, as an example, a vision mixer and the frame, or an audio console panel and the core, but it is also used for the lighting. It is the same network, the same gray network. Something that's interesting for the drama studio is that in the studio floor, we only use moving light, nothing but moving light. So it's really easy to recall preset between the various shows with very minimum setup time. And the height of the lighting truss, maybe it's not the right word, but yes, it's motorized, but it's also controllable via IP. And there's a high precision position encoder. So with the preset, each one of those truss, they can go at the right height automatically. So that really helps to have more shows per week in a single studio.
Okay, do we want to jump to Bill asks, what other tools are you using for network analysis other than Prism?
Many different tools. So if we talk about, I mean, the Prism is our main replacement of the good old waveform monitor. So that's the tool that people will use in operation in the control rooms at the acquisition to monitor if the signal quality is there. It's also good at looking at the quality of the 2110 stream, but we also have specialty equipment where we can dive into more precisely the signal. So it's more a lab, so more lab tools than production tools. So it's used by engineer to troubleshoot or to when we have compatibility issue between equipment. So we have things like BridgeTech WB 400/420. We use EBU List, that is also an open source software that we are contributing to its code. We're using some packet storm equipment. We're using Matrox Vero, which is a generator, a reference generator. Many more, I guess.
And you forgot my favorite, which is Wireshark, because very, very often we still have to dig at the packet level to understand what is happening. So we do a lot of packet capture and analysis using Wireshark.
We have Fabrics devices. I mean, we probably have most of the tools. Usually, especially at the beginning, not all of them would cover all the feature sets. So you always want to cross-check or have the other one. Now, as we gaining maturity, I think those tools get more complete and sufficient. So now we're just talking about the tool that can look at the streams, but also there's the whole question of monitoring, where it's very important in IP that you have a very good monitoring, because unlike SDI, where you have one signal per cable and you can go to the patch bay and just quickly look into waveform monitor if your signal is good or bypass that signal quickly. In IP, all these signals are blurred into the network. And if you just take one fiber optics of 100 gig, you have hundreds of streams. So you need to understand where are the streams going, and when there's a problem, where is this problem? Is it the source? Is it the destination? Is it somewhere in the network? Is it the synchronization that the equipment is not getting? Is there a general PTP problem on the network, or a localized PTP problem on the network? So you need a lot of visibility on your devices. So for that, we'll use a number of tools. One is SolarWinds, where we aggregate all the different SNMP traps. We can ping the equipment. We can analyze the quality of the. But basically, what's the equipment are casting. We are also using some syslog. So we're logging, because a lot of these equipment, especially the network and some devices, they generate a lot of verbose information about the states, and also it's useful for troubleshooting. Smart Dash that we're testing also it's getting used in production. So a lot of different tools to really cover I would say recover the visibility we used to have and the speed of reaction we used to have with SDI.
Okay.
So, Peter, I was just jump in here and go for a non-technical or equipment-related question. There's one here that says, in your mind, was it easier for networkers to understand broadcast or broadcasters to understand network?
Ask Jean-François.
Oh my God. Well, I only have a partial opinion on that, which is the broadcast people, when they are really technical savvy, they can dig in and grasp how it works for IP. But all the IT guys I know in-house doesn't need to know much about broadcast, because they're so busy just to make the network goes that they don't need to. They don't have the time to.
And I think that's a good point, that we don't expect every people to understand the full stack. With this technology, you really need to team up networking people, IT people with people with the broadcast background and the understanding of the video, the audio, and the application, and work together. I don't think there's a way where you could from day one build a full crew that would have all this understanding, and the IT spirit is a layered approach, where you have this network and these servers and this compute resources that needs a specific skill set to use, and the application people who need to consume those resources. So going with that model, we don't necessarily need everybody. You mostly need the vocabulary to understand each other. And I think it can come with.
I really don't think that even right now, there's nobody in-house that knows everything about the broadcast and the IT, except maybe from Francois and Felix, but I'm just kidding. But it's really a really wide skill set, and you need a team that work together to make it work.
Something we did that really helped before starting the project is that we merged both teams. So the IT teams and the broadcast team is now the same team.
and that was key to the success of the project. Something that I truly believe is that the broadcast industry is full of curious people that likes to learn new technology, and that's the kind of people you need to do a project like that, because it's not important their background, but if they are curious and if they want to learn, they will not understand everything, but they will understand what they need to know to do their work, and they will ask the other guy for what they don't know. But they need to be curious and not afraid of the technology, because if they are, then they will not like that new world out there. But that's a minority, and yeah, and I think that most people that work on the project really liked it, because it was a great opportunity to learn from the other guys.
Yeah, and the exact same aspect apply to the support team also.
Yeah.
You really have to have people that like to learn by themselves and progress into that. If not, well, they will miss the train.
Something that's important if you are joining or starting a project like that, something that we realize maybe a bit late, is that early in the process, you start with a small team, and those people will have 1 hour more training than the other, and then a day more than the other, and then a week more, and then a month more, and eventually they are so ahead of the rest of the team that you always go see those guys, and they develop much faster than the other. So lessons learned, and if we were to do it a bit differently, we would definitely try to start with a bigger crowd to begin with, and not only a few key people, and that would have made our life easier downstream of the project.
Okay, do we want to just quickly touch on, Al was asking about timing setup. How much time is timed by PTP, master clocks, that sort of thing?
Everything that's 2110, and that's a lot of equipment. A very high percentage is native 2110 is clock using PTP. For stuff that it's SDI, there's always a gateway in front of it, and then that gateway is clocked with PTP. There is a few equipment we have, like the Ross Acuity chassis we are using here. The model we use doesn't exist with 2110 IO, so we had to buy SDI version of it, wrap it with gateways on both sides, and then of course that production switcher is clocked using Blackburst or tri-level sync. It is and in order to minimize latency, that production switcher is frequency locked with the rest of the system, but it's not a frame integer value with the rest of the system. Basically, we have a few hundred lines of delay to be able to have gateways in front of the switcher that can tolerate wide packet, because in the 2110 spec, there's two types of senders. So you need a gateway with a bit more buffer if you want to tolerate wide senders, and the output of that gateway then feed the switcher. And in order to save some milliseconds of latency, the switcher is 200 lines late compared to the PTP reference. And the output of the switcher, we have two feed. One that is we make as fast as possible, and we don't frame sync it for the monitoring, so it helps to minimize the perceived lip sync issue in the control room. And the signal that goes on there, this one is it's rounded up to the next vertical interval. So there is a few area like this in the building where the timing is a bit complex for. Yeah, it would have been easier if everything was native IP. In terms of the PTP architecture, we have 3 grandmaster. Why 3? Because very early in the process, we felt that PTP was really critical. And we decided to go with 2 different vendors. So we have both Meinberg and Evertz in the system. They both have their pros and cons, so nobody's perfect, but the combination of both we thought was a very good combination. Those 3 antennas are not at all in the same area of the roof of the various buildings, so they are spread out in order to get a physical redundancy. We have a small PTP network where those 3 grandmaster are connected, and that network of 2 switches then feeds every spine we have in the system. Yeah, we can do a whole presentation on the PTP ecosystem. And where I will finish is that no matter how well you plan, no matter the amount of redundancy, we had a failure last week that caused on-air issues. And it was basically, we lost all 3 grandmaster at the same time due to a human mistake, because no matter what you do, human mistakes are always possible. But we learn in that process. So, and that was a good occasion to really not learn, but see in action. Then when you lose PTP, those systems will not freewheel for a very long time before having major syncing problem. So, yeah.
Good summary.
Yeah, that's it for PTP.
Wow. Okay. This is a question I was going to ask as well. What technologies, processes, and protocols have you adopted to mitigate cybersecurity? I'm concerned, like, because you're all IP, what about hacks and attacks? And or is your production separate from the internet? I assume not.
Yeah, so security is clearly a very important topic. A little bit like my answer for Nmos is that when we started the project, that the industry was not really ready to have this conversation. We were asking for security, but the energy of the industry was to basically provide the 2110 flows and you know, the basic functionality of the equipment. So we included a number of requirements in our RFPs and our contract with our suppliers. And it's based on the EBU R143 questionnaire asking what is the security measure taken by the different suppliers, and a list of tests covered by EBU R148 that we've done in the lab when it was time to select equipment, but mostly now we're also doing a general audit of our installation to identify all the missing parts, that the weak links in terms of security. And sometimes it's quite basic, you know, the typical there's no password on SSH, basic issues like that. So we're working actively with our providers to fix it, and also we're working at the network level to mitigate those risks and to close the doors using ACLs, using different mechanisms to make sure that it's not easy to run into those devices. Anything else?
Yeah, that's it.
Well, correct me, but one question was how are all of these networks separated, and then the production and the presentation network are not accessible from the internet. Correct me, Francois and Felix, but
yeah, no, that is true. There's there's no network that is totally air gap because the output of a studio need to play out. So we cannot really air gap play out from production, but we can do a lot to segment the network as much as possible. So yeah, we have what we call the campus network. Right now, I'm having that meeting with Felix from the campus network. This is the regular workstation. We have what we call the business and media network. This is where all the server-side equipment are located. And of course, there's way more security on the BME network than there is on the campus network. Then we have for real-time signals, 3 networks, the red, the blue, and the gray. Red and blue is for 2110 streams, audio or video, doesn't matter, it's the same network. And gray, the gray network is it's something a bit special. It's often it's a virtual network that may or may not share the same physical network as the red and the blue. So yeah, I will try to make that clearer. There's a lot of equipment that have in-band control for the control of the equipment. So it's going to be the same physical interface as the real-time signal. It's not going to be the same IP address. It's not going to be the same router, but it will go from the equipment, from the same network interface into the same switch on the other side. Switch, everything is layer 3 in our system, so it's a router. And then inside that router, we have a separate VRF for control signal. And there's area where there's a bunch of control signals together. So then we can have a switch that only have gray network connectivity. So that's our way to deal with control versus audio and video signal, in band or out of band. The gray network doesn't have at all the same redundancy scheme as the red and the blue, because there's no such thing as -7 on control signal. And there's very few equipment that supports LACP redundancy. So that's why the gray is managed slightly differently for the redundancy scheme. And yes, we have a gray, red, blue. There's one segment for playout and one for production. So basically we have multiple zones with multiple control in place to try to restrict the network if ever there is a problem, being a human mistake or a hack or a hardware failure or a software failure.
Also, I think this was covered in previous presentation, but there's no like single solution for safety. It's really a matter of having multiple way of securing yourself, and we have also an internal team of IPsec that scans everything and checks everything and gives recommendation about anything they found, like stuff that have easy password to guess or stuff like that.
And Felix talked about the EDU R148 not checklist but test plan to assess the cybersecurity of an equipment. And we have done about 80% of the coverage of everything we install. And I believe that we need the help from the industry to take that a little bit more serious, because those test plans are public and we find a lot of stuff that it's not, yeah, let's say that some of our partners could have caught it first in their own lab, but I think it's going there. It's yeah.
Okay. Sorry, Tony, did you want to say
Yeah,
something?
no, I was going to add one. Julian has a question here. When the facility was first developed, how much of the overall ST2110 solution was deliverable in the real world, and how much had to be engineered as the project went through to deployment and completion?
I would say 0. That's really honest. When we started to reflect on the architecture of the building, 2110 didn't exist. It was still PRO3 from VSF. And at that time, many proposals were offered to the market, like Aspen, like NMI from Sony, and 2022-6 from SMPTE. So 2110, for sure, nothing really existed. At that time, we wanted also to work with as many software solutions as possible, and very few were available. And was 2110 achievable in software? It was not that clear 4 years ago. So that's why we sponsored the development of 2110 inside FFmpeg to try to play and influence the market and see what was achievable in 2110. So I would say that early on it was 0. And right now it is still not 100% because there is some equipment. I will not name too many manufacturers, but some of them, they just don't exist in IP today. So we have to use gateways in front of them.
Okay, all right. I got 2 questions that are kind of similar. Gord asks, what do you use for remote interviews or radio and video? And also Ryan says, what do you have remote studios for TV and radio? And do you convert those systems as well? How do you transport the signals back to the playout facility?
Yeah, remote interview. These days we do a lot of Skype, FaceTime, Hangout, Meet, Zoom, whatever on air. That before the pandemic, people were a bit reluctant because picture quality was not being good enough. And now because we had to do it, we do it a lot, and people got used to it. And I don't think it looks that bad on air. Whenever it's our own people or it's professional. For video, we use mostly Live View and Gero. We have both. They both have their pros and cons. And for radio, we use mostly Comrex equipment, but there's also small areas where we have other products, but it is mostly Comrex. Yeah, in terms of remote studios, a good example in Montreal, we have Studio Grande. Studio Grande, it's a facility that's about 10 kilometers from here. We have 2 control rooms over there, a few sets. This is where we did the Olympic production. The control room were there, but the central core equipment was all in the new building. And between the both facilities, we have dark fiber, and we are using Fujitsu equipment to multiplex data, and that's quite amazing because right now we are operating at 500 gigabits per second per wavelength. So it is quite dense, and it works really great. But that's only possible when you do have dark fiber. In terms of regional sites, we have a bunch of them, and how we get their signal to the main facility is using a network that was built by Rogers many years ago called NGCN, where we use Evertz G2K codecs, and it worked great. So yeah.
Okay, Brad wants to know how far you push the envelope as far as picture. Have you done 4K, HDR, Rec 2020? How far have you pushed that, and what is the system capable of?
So we build the whole facility with, and one of the benefits of IP is its ability to evolve without having to change everything. So we decided to go with a 25 gig network with 100 gig uplinks. And this allow UHD on every device, since it's a bit more than 10 gig video and plus the audio and everything. It would not fit in a 10 gig network. We have done also pilot project to really study HDR and UHD in production. So our teams have played with it and are aware of the production possibilities with this technology. A number of the equipment in our general television are also 4K ready, so they can produce 4K. So we have everything, or almost everything, to produce a 4K show, although we start by walking rather than running, and now we start with HD. But with switching to 4K dose equipment, with adding a few more pieces that we have not yet in 4K, we are very close to be able to do 4K production. For general television, for news, we don't really consider that format. The next upgrade of the format could be 1080p, but it goes also with all the news editing system that we use needs to support it, and also these are upgrade paths in the future. But again, the beauty of IP is we don't need to change all the cabling in place for those future formats.
So
Okay.
question, I was just going to say, Peter, question here from Danielle is, would you think that other mid-size or small-size broadcasters could trust moving to IP in general, specifically production, radio, and TV? Or is it just a big organization that has lots of resources?
What would you suggest, Carlson? As for the technology itself, it works. And you've seen the presentation that we played. We did that live with the production crew, and it was flawless. So there was a little thing on the microphone, but probably it was more a wireless issue than an
and it
IP
was not
issue.
an IP microphone. So.
Yeah, exactly. So the technology works, and it is stable, and it's getting mature as an industry. I think it still require on the knowledge side, on the preparation side, we're still in the learning curve again as an industry. And for us, we're doing our integration in-house. So we have this ability to also train the people and bring people up to speed. On the market, there's a lot of system integrators. So I guess everybody is learning as we speak. So of course, if you need a kind of, I don't think you can expect for today that this will be like an SDI replacement in terms of speed of installation, in terms of knowledge of operation. We will get there. We're probably a couple of years before we can really replace that. So I think the organization who will want to do that shift is because they gain some benefits from the new technology. It can be in the workflows and can be in the centralization of the backend equipment, remote production, 4K. There's a number of places where it worth probably the extra effort at this stage. And for a very small system, actually, now that we know how it works, we script our deployment, we have templates for our network. So it's really a question of knowledge. And, you know, for a future regional station, we could consider doing that, but we needed to learn it first. So the key is really the maturity and the know-how of the people.
And if I may, to complete the answer, we have other projects at CBC. Of course, Toronto, it's a big production facility. It's bigger than in Montreal, and the core of the 2110 network, we are installing it, and as we speak. unfortunately, the switch we have here in Montreal, the core switch are 100 gig switches. In Toronto, now the Ethernet technology, for not that much more dollar, we could get 400 gig. So the technology goes really fast, and you can get huge system at a reasonable cost. For small system costs, I would say that it's not. It's probably more expensive IP than SDI for now. But for larger system, I would not say that. We have Vancouver. Vancouver, we will replace both the radio and the TV router with an IP system. It's basically a copy paste of what we did in Montreal. It's the same switch model and everything. So this is also happening as we speak. For very small regional station, maybe I can ask Jean-Francois what he's doing in Rimouski tonight, but it's to install an SDI router, right? So.
Yeah, I'm currently replacing an SDI router for an SDI router in Rimouski, and I think one part of the question I like to say that could be a game changer is that if you move your facility or not. Like in Rimouski right now, we have all the DA, all the distribution, everything is already there. So there's not much to gain from the IP side of thing. Everything else in the station is SDI. So there's not much to gain. But if we were to move the station or start from scratch, maybe it would work to ask the question.
Yeah, and if you have a workflow reason or a business reason, then it would make sense. And in Rimouski, they had to keep their existing workflow, and SDI made sense for that project.
Well, I heard that Rimouski is going to be the first place where ATSC 3.0 is going to go, right? Anyway, that was one of the questions. Sort of side off topic of IP infrastructure. Are you guys getting ready for ATSC 3.0?
No.
No. Okay.
Question.
The short answer, huh? Is there another question in the bunch that you'd like to answer?
Well, I've got one here. David has asked a couple of times, can the orchestrator make network changes or configurations such as QoS to prevent link overloads? And he also asked the question, can the orchestrator make network configuration changes?
Oh boy. Okay, that's a good one. If by orchestrator we mean the VSM broadcast controller or orchestrator, we have today the system works in IGMP, and basically in IGMP the orchestrator talks to the end device, then the end device asks to join flows using IGMP, and then there's PIM involved in the network to make that happen. So the orchestrator, I would say, doesn't talk to the network at all. It talks to the end device through the network, but not to the network. There's some limitation with IGMP. So the long-term strategy is to move that to an SDN control network. We are working on it as we speak, but it's today it's not deployed. And in that model, then the answer is yes. It's way more than just QoS. There's policers, because the orchestrator knows about the bandwidth of each one of the flows, and it will be able to talk to the network to put policers in place and stuff like that. So there's much more bells and whistles that will come with it. But for now, it is strictly IGMP and PIM that we are using.
And that's a very good question, because I don't think as we speak, there's a one unique answer to that question. As an industry, I don't think we have found the holy grail of how the network will be controlled. So we're still exploring, trying there's different approach, different controller are doing different strategies, bandwidth reservation, static routes, can be whitelisting IGMP groups. It can be there's a lot of possibilities. So we're really tuning up, and especially we were talking about 4K. While we are in HD, you know, we have the bandwidth to live with IGMP probably for a big while. But once we load the system and we get close to the limits of the backbone of the system, this is where we will want to have a tighter control of all the flows on the network. And I think we're still trying to find the best way to do it. And if anybody has the answer, call us.
Maybe something that it's really important to mention, and it's I'm not sure it is part of the question, but it may answer part of Daniel Collin question. To deploy a system like this takes a lot of time today, not just to train the people or help the technology to mature, but just by the fact that there's much more parameter to control. There's much more things that can fail. The resources to do that job, you cannot multiply them or clone them. So yes, we are trying to attract talent. So if people want to work for us, Montreal, Toronto, there's open position. But we also need to work wiser, smarter, and that means automation. Felix, Alex, Sunday, and myself, we made a paper in the Motion Imaging Journal in July that explained how we use automation to automate the configuration of end devices, but also of the network. So the network, no, it's not configured or controlled by the broadcast orchestrator, but the deployment or the configuration of the network is 100% fully automated. And that, I believe that without that, it's impossible to deploy such a facility without having hundreds and hundreds of people involved. The size of the team, there's from the engineering team and the maintenance team, it started with 2 people, 3 people, 4 people. Then we reach a plateau of, I would say, about 60 full-time employee working on the project. And now we are on the phase out. So we slowly relieve people. So that's why we can afford to have Jean-François in Rimouski and not with us here tonight. But still, it took a significant amount of people to make that happen. Yeah.
Okay, another question here. How does any of the 2110 infrastructure that processes video in real time use virtual machines or HCI? And do you have any plans to use 2110-22?
Okay, so we did test, and that yeah, maybe Grass Valley, you will not be happy with my answer, but we early on the process we did test to virtualize ITX, and to be honest, it worked much better than expected in VM. However, we decided not to do it because by itself, the ITX application, we can run multiple instances of the application on the same machine so that we can fully utilize the processing power available on that specific machine. And we thought that the to pay support agreement to both Grass Valley and VMware was not worth the extra benefit for that use case. So we decided not to virtualize. However, we have other process like the closed caption encoder from EEG. This is fully software. It runs in UCS, and it works really great with 2110, and we are using it virtualized. So I guess it depends on the use case, but truly virtualized 2110, there's really not much. However, software-based 2110, there's a lot of it. And those applications, all of them, we can run multiple instances on the same hardware. So we fully utilize the hardware. And we were able also to quite standardize the type of server we are using. So yes, sometimes there's a GPU, sometimes there's no GPU. Yes, sometimes it's a 100 gig NIC or 200 gig NIC. Sometimes it's 25. Sometimes there is a lot of hard drive for caching of video files. Sometimes there isn't it. But other than that, it is quite similar. And so I think we got some of the benefits, but not all of a true virtualized solution.
And on a -22 question, we're not using it. -22 being the compressed video over in the 2110 world. We're not using it, especially locally. I mean, there might be some application for long distance out of sight application, but as we speak, we're not. It's all uncompressed -20.
Okay.
So, Francois, there's a question here about the in your presentation there was comments about lip sync or audio going faster than video, but the comment here had suggested that doesn't PTP take care of keeping the audio multicast signal aligned with video? But I understood that to be just a latency problem, not a drift or something problem, but I could be.
Yeah, you're right in the sense that PTP is providing precise time for all the devices, so they can be synchronized together. But indirectly, also PTP time is used to timestamps the different signals. So you could expect that an audio stream and a video stream coming from two different devices could be realigned based on that timestamp. And this scenario can work, but on a one link hop, where you have the audio and the video produced by the same device that will go through different paths, and the receiving device could use those timestamps to realign this. But in our production world, we have complex system, and each of these streams, the audio from the microphone going to a processor, going to the mixer, going probably through even a wireless microphone before that, will have his own path where the timestamp is not necessarily preserved. So you cannot use those timestamps to realign this. So you need, as we speak, to use the good old way, which is to include delay compensation at some key points in your system to realign your audio and video. So that's totally independent on the fact that all the sources are perfectly synchronized to a clock, but they go through different stages and they accumulate some delay. Now the SMPTE is working on a revision of 2110-10 that aims to use those timestamps in a way that they are preserved throughout the chain and can be used for realignment. But that's a new version. It will need to be implemented by vendors, and you'll need to buy those equipments that have this capability. So it will take a few years before getting rid of this fully manual way of compensating the delays in your system. But there might be a solution for better making this automatically, and if it's not automatic, at least that you have a better measures of your delay in your system that you can apply the compensation. So PTP is not going to solve this problem by itself.
So
Okay.
we've got about 6 minutes to the top of the clock, and we should kind of wrap it up because we could be here all night. So if there are some important questions here, we've got still 9 in the queue. I'm not sure we're going to get through all 9. Is there one that speaks to you to suggest that we should hop on that one?
There's a question on touch panel control surface. Do you have a feedback from operations?
They really liked it, and the reason is that they basically they have the tool to configure them the way they like, and they really liked it. So yes, this is a big success. And it's for many type of equipment. We have the VSM panel virtualized. We have the Lavovis tool that we use to create virtual interface. We have dashboard for Rust from Rust that we believe it's a great product that we use to build custom interface. So, and we have also IDS. Again, that IDS it's the system that we use for tally management and the clocks and some virtual panel. So with all of those tools, yes, people really liked it. So that was easier than expected to switch from hardware to software panel.
Well, I think that's our last question, right, Tony?
Yeah, I think we should, because it's
getting late.
Yeah, it's getting late, and yeah,
into my beauty sleep. Okay, cool. Yeah, so I want to thank our panelists. So Francoise Legrand and Felix Pion and Jean-Francis Prayer for their time, and they've been very generous to SMPTE in general. They've done several SMPTE presentations, during the build of this building, and they've been very busy with the building of the building. So I really appreciate the time that they've put in to educate the rest of us and the community. So thank you very much. Do you want to take it over, Tony?
Yeah, I'll take it over.
Cool.
There is a couple of slides that I'd like to end with. We have recorded, or we are recording the session right now, and we'll make it available on our YouTube channel. Give us some time to do that, because there's a lot of editing that has to happen. Again, there's an election process happening right now for some of us. It's Canadian governor, and so if you've got the email, please partake. We have those are the dates for our future meetings. We did have NAB as a wrap up for October the 19th, but that's not going to happen because that guy got canceled. So we're in the process of getting another topic, and I think we're going to talk about virtualization sets and things of that nature, workflows. Some information, our website. If you're not a member, you want to become a friend and get our mailing email blast. There's the link. There's a few social channels, and that's a wrap. Be well, be safe, and guys, thanks very much, and really appreciate it. Really good evening. You can tell by the amount of questions that we had in the queue that people were engaged. So good going, and hopefully soon we'll be able to travel, and then we can knock on your door and come for a real visit as opposed to a virtual visit. So thanks very much, and we'll see everybody next month on October the 19th. Thanks, guys.
Thank you very much.
Thank you.
Okay.
Bye-bye.
Bye-bye.
Bye-bye. See you later.